We're building the James Webb Space Telescope in order to be the scientific successor to Hubble. Everybody knows and loves Hubble. Hubble's amazing. But there are some things it just wasn't designed to do, and there are many ways in which we've pushed Hubble to its limits. The Webb telescope will be by far the largest telescope we've ever sent into space.
We're building this telescope because it will be much better and more powerful than what we have. And so, of course, why would you need a better and more powerful telescope? It's to make discoveries of things you can only guess about. Nature is always full of surprises, and very rarely do we predict things the way they actually are.
One of the most exciting things about this telescope is the opportunity for us to see those very first galaxies that were born in the early universe. The James Webb Space Telescope has 4 primary science goals. The first of those is to detect the very first galaxies that were born after the Big Bang. The second is to see how galaxies form and assemble over time and how their black holes grow. The third science theme is to study how stars and protoplanetary systems are born. And then the fourth is to learn more about planets and the origins of life. The primary mirror of the Webb telescope is about 21 feet across, and the mirror segments are made out of beryllium, which is a very strong, lightweight metal that holds its shape very well under large temperature changes. So the 18 mirror segments have about a golf ball size worth of gold that's spread very thin across all of the mirrors. The reason we use gold to coat the mirror is so that the telescope will be highly reflective in infrared light. The biggest questions we have in astronomy right now really demand an infrared telescope.
Infrared light is sent out by objects that are too cool to emit visible light. Things that are very, very far away, like the earliest galaxies, they send out visible light, but it's stretched out by the expanding universe so that it becomes infrared by the time we receive it. So for these 2 main reasons, we want to study infrared. There's even a third one, which is that the infrared is able to go around the dust grains that block our view of dusty clouds, so we can see through the dust clouds inside to see stars being born. So all of these reasons make infrared a really wonderful open frontier for science now. The Webb telescope is going quite far from Earth. It's going to an area we call the Lagrange point L2. So it hangs out there about 1 million miles away from us. It's about 4 times away as the moon is. The Webb telescope will be very folded up before it goes up into space. Along the way, shortly after launch, we will begin to unfold it. This all takes place over the course of a couple of weeks.
It will be about the size of a tennis court, the sun shield is, and it's about 4 stories tall. So in comparison to Hubble, for example, Hubble's about the size of a school bus. Webb is more the size of like a 737, so it's huge. In building and designing and the whole process leading up to launching the telescope, there are well over 1,000 people that have been involved in that. So the Webb telescope is an international partnership between NASA, the European Space Agency, and the Canadian Space Agency. There's a whole world of scientists waiting to get the data from this telescope. So it will affect not only astronomers now, but also the kind of astronomers of the future. Those kids that are in high school now or college will be able to use data from this telescope. One of the reasons I love astronomy so much is that it gets to the heart of our big questions, of humanity's big questions. You know, where did we come from, and how did we get here, and are we alone, and how does the universe work?
Well, for me, building the equipment that can make a great discovery has always been like one of the most honorable things one could ever do. And to me, this James Webb telescope is the pinnacle of what I could imagine working on in my professional life. I can't imagine anything better.